When we get these scatter plots out, something we want to do is be able to describe them and describe the different features of it, and specifically look for these linear trends. So we can describe some different features that we'll look at here. One thing we can describe is the direction of our scatter plot. So our direction could either be positive or negative or neither. So having a positive direction, what that would look like for our data is we want to see an increasing nature to it. So what our scatter plot might look like is something like this. And with this, we kind of want to imagine this line that would be going through our data as best as it could. And the idea is that if we had this line, it would have a positive slope to it. So it matches with increasing data, positive slope, positive direction for the scatter plot. And it's similar with negative, where there should be a decreasing nature in our scatter plot. And with this, if we imagine that line, if we had a line going through this data as best as it could, it would have a negative slope to it. Then when we have neither, with neither there can be kind of two instances. Well, actually, way more than two. One thing that could be happening is curved data, which is something we'll talk about that we want to avoid as we go through linear regression, because we want to see these lines coming through. But if we have curved data, it kind of mixes positive and negative, and with that, we just say it's neither. Something else that's going to come through sometimes is where if we plot data and there's just no real relationship between them, no association, what we might see is something that just kind of looks like a blob of dots, something like that. And with this, both of these would be that they have neither direction. This isn't clearly showing any increasing or decreasing nature, so we would just say it has neither direction. Then what we could do is describe the form of the data. So we have linear data, and linear is what's coming through up here. So where we can imagine the straight line going through the data. Curved data would look like what I drew up here, or it could even be more subtle than that. It could almost look linear and then at some point kind of do something like that. And the idea is maybe for a while we could imagine this straight line going through, but if we continued the line, we would miss a big chunk of the data. So in order to keep capturing the data, the line would have to curve over. And we want to be careful of this curved data for when we move forward with our calculations, because it's all based on we need a line coming through. And then for no pattern, that is what we see right here. That's where we get that blob of data, where there's just no real trend. Something that happens with the data that doesn't have a pattern, where it's just no real trend here, if we try to graph a line, what technology is going to do is it's going to send a line horizontally through the data. Because it's the idea of an average. It's like if we were trying to estimate where we would land along the y-axis, we're just going to assume we'd land somewhere in the middle. Because while here you get the idea that, as we move up with x, the y values would decrease. Here we don't really know, so it's best to just work with an average. Then we could talk about the strength of the data. So our data could be strong, or it could have moderate strength, or maybe it has weak strength. And what this is describing in terms of our linear trends, if we have this linear data and we're imagining that line going through the data, in fact with these, let's say I draw the line first, and my data is going to fit around these lines. The strength is describing how well the data fits this line, kind of how far is it departing. In that if we have strong data, all of our data points are going to be pretty close by this actual line that we have here. Whatever line of best fit we get out, all that data is going to be closely fitting to that line. When we have moderate strength, it's going to spread out a little bit. We should still see something that's roughly linear, but it just varies a little bit more. It departs the line more than when we have a strong strength. And then weak, where we have this linear trend here, it might barely fit that line. So with this, we're going to have much more variability in our data coming through. Even though we might see overall linear trend, it's going to depart pretty far away from it. So that's how we determine strength. It's how well does it fit that linear trend. And then the last piece we want to look for are these special cases. We want to be careful of outliers, and we also want to be careful of any groupings. So what it would look like if we have outliers, it would look like we have data that's very clearly linear, or we can see where there's an obvious trend, and then there's one point out here, or there could be 2 or 3, but it should be minimal points that kind of depart the trend of the data. And that would be showing an outlier that's either an extreme case that occurred, maybe someone mistyped the information when plugging it in. We want to be careful of these outliers because eventually when we use a number to describe the strength, it can be affected. Because when we make this line of best fit, the line should mostly go through the data, but if we have a point like this, it might throw off our line a little bit. So we want to be careful, and the very last video that we'll do here is talk about outlier analysis and how to determine whether or not something is an outlier and how to analyze that. Other things we want to be careful of are groupings, which is where we might see data that has a clear trend working together, and then maybe there's a gap, and then some other trend occurs. The data disconnects. And what this would show is that within our data, there's 2 separate groups. There's some characteristic separating the groups, which would tell us that we should analyze the data separately. No matter what there's some characteristic that we could separate the data itself by first, so that then we could describe this with linear regression and separately describe this with linear regression. But to work with it together isn't going to benefit us because we can't make one nice line going through the entire set of data. So when we get our scatter plots out, typically we'll want to go through these 3 pieces in describing it, and then this last piece is more of a warning, things we want to look out for.